All right, welcome to the study hall for August 23rd, 2012. Our topic for today is the second part of testing cases in data sufficiency. Continued from the last session. So as usual, we got to kick it off with things like here are the rules, here's the nitty-gritty, whatever. So let's do that. You guys know the drill by now. Let's look through it real quickly. Don't submit problems that are too general. Don't submit problems that are too specific. Too specific means one particular problem without a more general question attached to it. Please don't submit that. That's why we have the forum. So if you have those kinds of questions, please ask on the forum. Too general, if you have a question that amounts to asking about the entire GMAT at the same time, doesn't make sense for a single study hall. That's why there are 1,000 pages of strategy guides and a whole 9-session course and everything, because the GMAT is a lot of material. So if you just ask, how do I solve problems faster? I mean, we had one submission in the last couple of weeks that was like, how do I solve quant and verbal problems? That's the entire test, guys. So careful with that. Finally, don't submit your personal issues. This is not the place for that. We have a folder on the forum that is the place for that. It's called the General Questions folder. That's where you can submit questions like, here's how I've scored and what should I do, and so on and so forth. And we also, if it's particularly about admissions and schools, we have a partner firm who runs a folder on our forum. That's the MBA mission. They run the Ask an Admissions Consultant folder on the forum, so please check there. What we should see is topics of intermediate depth. This is an example of one. If you do ask a specific problem, please tie it into a more general question. Also, you have to tell us where the question comes from. People have been not doing this as well lately. So make sure you know that you have to do this. You have to tell us where you got the question. So what's the source? Can't use the official guide, but whatever the source is, please tell us, even if it's ours. We have like 3,000 questions in our test software, and we have 1,000 pages of strategy guides. So even if you give us one of our problems, we're not necessarily going to recognize it. So please tell us the source. Also, please check the archives for topics. There are now something like 70 archived sessions. So if you submit a topic, please check to see whether we have already covered it. There's a lot of, please don't move things around the board. Okay, now you can. Please check to make sure that we have not covered your topic already. If we have covered your topic already, then please check what we've covered of it. Let me go ahead and type this on there. If there's an aspect of the topic that we haven't covered, then that's where you would want to go ahead and submit that topic. So if your topic has already been covered, please watch the video. And then if there are aspects we haven't yet treated, then submit those. So make sure you do that, please. Also, another thing to be aware of, make sure you don't ask for, topics that are too central. Meaning, these lectures are not meant to replace our course. So what we're not really going to do is, here's an overall strategy for reading comprehension or something like that. That's why we have the main course, our flagship product, the 9-session course. So for the overall comprehensive view. The point of this study hall is to be auxiliary and to treat some extra topics that are not in the 9-session course. But it's not meant to be a stand-in for that product. So if the questions are if they synthesize too much or if they're too central or whatever, then we probably won't use those. So, okay, those are the rules. Anyway, If you understand, go ahead and give me the smiley face icon. Where you should see that, let me show you really quickly where that is located. If you look under your name on the left-hand side, you'll see these emoticons. You'll see these face icons and stuff. When I say give me a smiley face, if that means I'm referring to one of those emoticons. So if you guys all understand the rules, go ahead and give me the smiley face. Awesome. Okay. When we have questions, this whole version of Illuminate is pretty new to some people. What you should see on your board now, it just changed, is the polling tools, the multiple choice tools. Make sure you know where those are located. This is multiple choice answer. Those are the A through E. Those are located there. So when we give you a multiple choice question, including all the data sufficiencies that we're going to do today, your fellow people will not see your answers. But please do not indicate your answer publicly. So please don't indicate your answer in the chat box. And please don't click this twice. If you click twice, it'll erase the answer that you put the first time. So that's where you find the multiple choice question responses. Okay, any questions about the basic rules? We've been there, we've done that. I think we're on the same page, but are we all good there? Okay, so let's revisit the topic for those of you who just got here. The topic for today is testing cases and data sufficiency. So let's make sure we understand what testing cases means. So remember the basics of data sufficiency here. The basics are, remember what we're after. There's a very specific question. So when you first look at a problem, make sure you understand what that question is. Insufficient means that two or more answers are possible for that question. And then sufficient means that that doesn't happen, that only one answer is possible for that question. So and what you should do, what you should be sure to do, and we're going to make this more concrete as we go through these problems, is you should make sure that before you even start doing the work on any data sufficiency problem, before you start work on one of these problems, make sure you specify exactly what would be insufficient, and then make sure you specify exactly what would be sufficient. It might seem sort of weird that we would mention insufficient first here, but what we're going to see as we go through this is that there's actually, especially on the yes-no type questions, there's a certain advantage to be had by first specifying what is insufficient, as weird as that might sound. So let's go ahead and do a problem. Remember where your multiple choice answers are. I'll give you a timer. If you've been here before, you know how this works. So here's the first problem of the day. This is from our material. Please indicate your answers using the multiple choice tool. That's where you find it, underneath your name. And then before you start, make sure you know exactly what you are trying to do. Okay, go for it. You can put a timer on the board. There's a timer. Go for it. All right, everybody. Let's see. We still have some non-responses. If you are Caroline, Chad, Joel, remember the GMAT is a test where you have to pick something. So you can't not answer these problems. So just make sure that you know that that's the case. And if you don't remember where to find your answer options, remember where they are. They are right there underneath your name. So please pick something if you are one of those aforementioned individuals. There's a Kathy who just got here. Chad, please pick an answer. Okay, so here are your responses. So it seems like a lot of people like answer choice B here. All right, let's recap the main theme of the day. Today we're talking about testing cases in data sufficiency. It's one of two main approaches. Like there are really two main families of approaches to data sufficiency. The first of those is your like textbook style methods, like anything you would have learned in school or that you would, anything that you would consider a traditional way of solving a problem. That's where you would, that's number one. The other main family of approaches to this is testing cases. It's a good team. As you'll see, you really want to have both of these methods at your fingertips. But you want to be good at both, but make sure you know that when textbook methods don't work, you have to test cases. This is a problem where textbook methods do not work. This is a problem where you actually can't do algebra. Does anybody know why? If you watched the last study hall, you'll know. On this problem, you can't use algebra or textbook. At least not on statement one. Yeah, it's because of this. It's because if P and N are integers, it's not because there's two variables, because there are plenty of situations where you can do traditional algebra with two variables, but it's this. It's the integers. So if you have things that are specified as whole numbers, then you cannot use algebra. We did make this point in the last session as well. So if you weren't in attendance for that, make sure you go back and watch that. If you have whole numbers, especially in a sufficiency problem, algebra is powerless to tell the difference. So whenever you have something like this, algebra cannot tell the difference between integers and things that are not integers. It's actually impossible. Like there's no algebraic tool that distinguishes between whole numbers and not whole numbers. So what this means is that you cannot solve this problem with algebra. It means you're going to have to test cases. So let's review what we're talking about when we say testing cases. So real quickly, when we say testing cases, what we're talking about is you try possibilities in an organized order or some sort of, it shouldn't be random. You should organize your approach in some way. As far as how to organize, it's going to depend on the problem, but you should make sure that you are not just throwing random numbers in there. Like if there's a sequence, you would put them in sequence. If there was multiples of 3, you would try 3, 6, 9, 12. If there are different types of numbers that you would try, fractions, not fractions, negative, positive, then you would try those in some kind of meaningful order. And if it's, if you're trying extremes, make sure you try all the extremes, but organize in some sort of way. If a possibility doesn't satisfy the statement that you're examining, then just throw it out. and then tabulate the results that you have. So if you only get one answer, then that's sufficient. And if you ever see a second answer, if you get two different answers, then you can stop. There's no need to keep going because you've established insufficient. That's what testing cases is. So what we got to do in the first problem, in the first statement here, is we got to test cases. Because again, there's no algebra that can possibly substitute for that. And I know I'm making that point over and over and over again. But let's look at it. So statement 1, the combined value, let's take this over to the next page. And let me grab those other observations as well. Okay then. All right. There we go. Oh, that didn't that didn't come out very well. Let's try this again. Sorry, that brief little technical hiccup there. Okay, what I'm trying to move over to the next page is this. There we go. On this problem, you can't use textbook methods. It's not going to work. So let's look at statement 1. It is, Suvik points out, this is almost identical to the first problem of the last session. Suvik, that is very true. It is very similar to that problem, but again, here's our class responses. It looks like some people have changed their mind at this point, but there's still a very strong majority in favor of the wrong answer here. So even if it is a lot like the last session, that doesn't mean that people are getting it correct. So the first responses here were almost all wrong. So still some learning to be had here. Okay, so the combined value of 5 purple chips and 7 orange chips is $53. So the first thing to do is specify the question. The question is, what is the combined value of 2 purple chips and 1 orange chip? So you're going to want to make sure that that's what you find. But remember to keep this question in mind as you go through this stuff. So before we start, we need to define what sufficient and insufficient mean too. So insufficient would mean that the combined value, the dollar value of 2 purple and 1 orange, can have 2 or more different numerical values. Sufficient means that at the end of the day, there's only $1 value for this combination. So it's, yeah, 2p plus n is the dollar value of this. So each purple chip is $p, each orange chip is worth $n. So let's just make a table. Let's test cases for statement 1. So let's say that if P, which is the price of a purple chip, and then N, which is the price for orange, and then this has to add up to 53. So the check that we need first is we need to check the value of 5p and 7n. And then we need to say what's 2p plus n. So notice what we're doing here. I mean, there's a certain amount of complexity that you have to be willing to deal with. What we're doing right here is we're just checking the statements. at this point right here. We're just checking to make sure that 5p plus 7n has to be 53. And then if we get values, if the values pass that check, that's when we answer the question. If they don't, that means they don't even satisfy the statement in the first place. And so we would just throw them out. So, okay. Let's say that P is 1. Let's say a purple chip is worth $1. So that would mean, I don't know why that was underlined. If a purple chip is worth $1, then 5 purple chips is worth $5. Remember that you have to have this equal to 53. This is 53, this is $5. So that means that this would have to be 48. That doesn't work because n would have to be 48 over 7. And no way that that's going to happen. So 48 over 7 is not an integer number of dollars. So this case is a non-case. This is not a yes to the question. It's also not a no to the question. It's a nothing. It's a we just don't even go there. So let's keep that up. If a purple chip is worth $2, this is worth 10. 53 minus 10 would be 43. So that would be 43 over 7. That does not work. Keep going with this. P for purple, 3, 4, 5, and so on. All the way up to, 10, because if you had more than 10, that would mean you have more than $53 already. So let's just try these. So these would be 15, 20, 25, 30, 35, 40, 45, and 50. So subtracting from 53, we have 38, 33, 28, 23, 18, 13, 8, and 3. Notice the other thing here, when you have multiple steps, just a quick organizational tip here. I mean, there was this dude about 100 years ago, maybe a little bit more, named Henry Ford. Probably heard of him. His idea was to make what's called an assembly line. It made him very rich. The idea behind an assembly line is that things go faster if people do the same thing over and over and over again. So if you have something where you have to plug in a bunch of numbers like this, you should take the Henry Ford approach and you should do the same step in a row. So if you have to do things multiple times, try to do the same task repeatedly when you have to do it, instead of going one case at a time here. Like notice we did all the 5 P's here at once, and we did all the 7 N's at once. So how many of these are multiples of 7? Well, that is. All of the other ones are not. So that's not 38's not, 33's not, 23's not, 18's not, 13's not, 8's not, and 3 is not. So we only have one case. We know that the purple chip has to be worth $5. And we know that the orange chip has to be worth $4. This is the only case that survives this Holocaust here. So that is the values of those chips. So P is definitely $5. N is definitely $4. So this is sufficient because we would have 2N plus P or 2P plus N or whatever. It's $14, but you don't have to. You don't have to go there. You actually got prices for your chips. So statement 1 is sufficient, much to the chagrin of the majority of the crowd. Question on the board: if the constraint is not there, can we use testing cases? No, you couldn't in that case. Then it would become a traditional algebra problem. That's correct. Okay, any other questions about statement 1? Please throw them on the board if you have them. Sorry, chat box if you have questions. So you got a test cases here. We only got one result. There we go. If we try statement 2, statement 2 we don't have to test cases because this is a special relationship. So this is where you got to be playing heads up ball here. So for statement 2, the question is not asking for n and p. The question is asking for 2n plus, or actually 2p plus n. Not p and n. In the first statement, that didn't help us, because in the first statement, this was 5p plus 7n, and that's not really related to 2p plus n in any way that's meaningful. However, notice that this is 6p plus 3n up here. There's a special relationship there. What's the special relationship between 6p plus 3n and 2p plus n? Yeah, it's 3 times as much. So if we know that 6p plus 3n is 42, then we can just divide both sides of that by 3. And so that'll tell us that 2p plus n is 14. So that's sufficient. The upshot of this problem is that both statements are individually sufficient. So your overall answer to the problem is going to be D. Any questions? I think someone is typing. Okay, by the way, while someone is typing, as an observation, you can also test cases on this problem. What I'll do is leave that as an exercise for you to do at home. You can also solve this by testing cases. Try that at home. In other words, you can take this same kind of approach right here. What's going to happen in this statement, interestingly, is that you'll actually get more than one set of P and N. But you'll only get one answer to the question. So you need to focus on the right question. You only get one answer to the question. Try it at home. In statement 1 and 2, it's okay. Subic, that's something that is a feature of the way these questions are written. I don't think this is anything that'll particularly help you solve problems, so I wouldn't, worry about it too much. But yeah, it has to be the same. Like, the answers that you get have to be consistent. They don't have to be the same, but they have to have at least something in common. And so if they are a single value, then they will have to be the same single value, yes. If there were multiple values, as long as you had some crossover, it would be fine. So like if statement 1 was either 14 or 20, then statement 2 was either 14 or 10, that would be fine too. But we got to overlap. Okay, any other questions about this problem? Chat box, if you got any questions. Nobody. Okay. Good deal. I don't think you guys were following me the whole time. At least you're on this page. Okay, let's move on to another one. How about this one? This problem is rather infamous on the forum, so you may have seen it before. If not, give it your best shot. It's from GMAT Prep. I'll give you a timer. There you go. There's a timer. Remember where to indicate your answers, please, ladies and gentlemen. So that's where you indicate the answers. And don't forget to understand what these mean before you start. All right, make sure you pick an answer to this thing, please. I know some individuals are changing answers. Changing answers, to make sure you use one click. Please don't click again. We have a couple people not answering yet. Let's see who is not answering. Fabio, you don't have an answer. And then we have a couple people with connection trouble, so let's take a look. Okay, here is what we have answers-wise. Kind of all over the place. Doesn't really seem to be a clear preference. So this means we're going to have some fun with this problem. Okay, well, let's make sure that we specify exactly what would be sufficient and insufficient first. So this is a yes-no question. So let's make sure we get this laid out on the table here, because a big part of the challenge here is that people don't organize stuff. Like, they don't really know what the goal of the problem is going into the problem. And that's what this tip here is all about. Like, you want to make sure that you actually know what you're doing before you do it. I mean, as simple as that sounds, the basic idea here is know what you're doing before you do it. So let's talk about that. What does insufficient mean in this problem? Chat box, please. What does that mean? If one statement is true, not. Yeah, you can get a, well, let's specify that further, right? Insufficient means, well, I mean, what do the answers to this look like? The answers to that question are yes and no. So insufficient means that you can get it to be yes and you can get it to be no. But let's specify, yeah, like what Subic is doing is better, like actually specifying it. So make sure you do this. Yes to this question means that x to the fourth plus y to the fourth is actually greater than z to the fourth. So, and then a no to this question would mean that x to the fourth plus y to the fourth is not greater than z to the fourth. Not greater than means less than or equal to. So let me change that sign. So, okay. There's not really a super simple algebraic way to do this, because if you, these don't work out to be simple factoring patterns or anything like that. On the forum, we've seen some people do some pretty crazy madness with algebra that kind of starts getting at it, but because the problem here is that if you like square this, then you'll get x squared plus y squared plus other terms. X to the fourth plus y to the fourth plus other terms is greater than this. So you'll get this stuff plus other things is greater than that. And then here you'll also get this stuff plus other things is greater than that. It's not super simple, because if you know that x If you know that A plus something is greater than B, that doesn't tell you that A is greater than B. But it also doesn't tell you that it's not either. So we want to be careful with that. But let's just, I'll tell you, this problem is on the forum in many, many places. I'll put a link to the forum in the box later. But the short version, I'll go ahead and link you guys after we discuss this. But algebra doesn't really happen in any sort of straightforward way here. There's no relatively simple algebraic argument. I mean, there are some things you can do that are a little bit crazy, but that we will leave to the forum. So, and let's look at testing cases. So, this is why it helps to define insufficient first. I mean, that might have sounded weird first, but insufficient is actually you can get two concrete things to happen. It's easier to define that first. Once you have that on the table, then you can talk about what sufficient means. Sufficient means that you can only get one of those two things to occur. Defining sufficient first is harder because it's weird. It's like, oh, only this happens or only that happens. That's not as easy to understand. Whereas defining insufficient first is a little bit more straightforward because you actually have two concrete things that must happen. So, all right, let's see if we can get these. So let's look at statement 2 first. Statement 2 is a little bit easier because there's no squares or any of that funny business there. So let's see whether we can get both of those. Let's try to get the yes and the no. This is what you're doing whenever you test cases in general. You're trying to get insufficient because you can't prove sufficient except by running out of cases. That's the only way you can do that, or by establishing a pattern that's going to continue beyond all doubt. On the other hand, insufficient is just, oh, hey, I got two answers, so boom, I'm done. So that's what we're trying to do. So let's organize the approach. Organize. So, yeah, even so, you probably might not have had this type of problem in particular, but you probably have seen similar things, sure. But remember that the GMAT isn't like school. So if you relate things too much to what you did in school, then there's going to be issues there. Okay. Anyway, let's organize. Vincent, that mostly has to do with organizing, like we're going to talk about here. I mean, if your approach was sort of random and all over the place, then that's one thing. But all right, so what we need to pick X, and we need to pick Y, and we need to pick Z. Subject to the condition that X plus Y is greater than Z, and then we need to figure out this and that, and then the result. So that's an organized approach. Make sure you organize things like this first. The constraint that we have to satisfy here is that X plus Y has to be greater than Z. So let's make that happen. Okay, so someone give me an X, Y, and Z that satisfy that constraint. Give me a case. The first case, we don't have to be that organized about it because we can just see what happens. And then once we get that, we can kind of regroup. Let's try 2, 2, and 3. So 2 plus 2 is indeed greater than 3. 2 to the 4th is 16. 2 to the 4th is 16. That's 81. So that's a no. So now we need to try for a yes. make sure you know this. This is what I mean by an organized approach. As soon as you get that, your only goal in life for the moment is to get a yes. So now you have a goal here. Your only goal in life is to get yes. I mean, fractions, we don't really need to get that fancy, right? I mean, getting a yes to this question is very easy to do because all you got to do is make these really big. Like, let's say we made these, I don't know, like 100 and 100 and nothing. Then x to the fourth is going to be a very big number. What is that, like 100 million, I think. So both of them. And then that's going to be nothing. So that's a definite yes. So we're done. It's insufficient. Any questions there? I mean, you can use negatives. Negatives are another way to, like, if you make z negative, I mean, let's say you didn't find a case like this. Here we're done, but let's say you got the yes first. Then if you got the yes first and had to try for a no, then then you could start using your negatives. You could start saying, let's let x be 1, and let's let y be 1, and let's let z be like negative 10,000. You know, then that's just 1 plus 1. But then this is some huge number, and so that would be a no. So negatives can actually help you. I mean, they're not your enemy. They're actually your friend if you need them. But so notice the point here is to be organized. The point here is that once you get one result, you have to know what other result you're trying to find. And that should also address the question about time from Vincent. I mean, if you don't know what you're trying to do, it's going to take you longer. So yeah, I mean, the question you got to ask yourself is, why did you use fractions? Is there anything in this problem that tells you that you should use fractions? Well, no, not really. I mean, if it really came down to it and you ran out of other things to try, you could do that. But what that means is, like I said, your approach isn't really organized. You're not really aware of what you're actually supposed to do, at least as much as you should be. So there's a lesson there to be had. Okay. Other statement, let's look at statement 1. Let's bring all this over to the other page. So statement 1 is not sufficient. Let's take a look at statement, let's take a look at statement 2. That is an oversized graphic. Okay, let's look at statement 2. So we're still going to try the same sort of thing. So let's pick x, let's pick y, let's pick z. Again, we have conditions that we have to satisfy here. In particular, we have to make x plus y greater than z. Actually, this is x squared and y squared and z squared. So as such, check x squared plus y squared and z squared, and just make sure you get the desired result. So if it passes that checkpoint, then you just try the result, which would be what's x to the 4th. Yeah, statement 1, sorry. This is statement 1. We already did statement 2. So just trying to see if you guys are paying attention. This is supposed to be statement 1. Yeah, on the last statement, we figured out that statement 2 was insufficient on the last slide. So, okay. it's very easy to get a yes to this problem. Just let z be 0. So if this is like 1 and 1 and 0, then 1 plus 1 is indeed greater than 0. So then this is a 1, this is still 1 plus 1, and this is still 0, so that's a yes. So what is our only goal in life now? Tell us in the chat box. The only goal in life is to get a no. If you guys are not doing that, then that is the source of like all of the issues that you're having with data sufficiency. I mean, as annoying as this sounds, the problem that people have with data sufficiency has nothing to do with math. It has to do with like, I am not organizing stuff. I don't really like, the problem is I don't know what I'm doing and I'm just like flailing around. For instance, if you're just plugging in fractions for no good reason, then that's an example of I don't really know why I'm doing what I'm doing. And that's where all the time goes down the drain. So you need to have a goal here. At this point, once you have that yes, your only goal in life is to get a no. Okay, so, yeah, there's no reason why x and y can't be the same. So how do we get a no? Well, we can't use negatives anymore. And so we're limited to numbers that are 0 or greater. So to get a no, you basically want z to the 4th to be as big as you can get it. So make sure you don't plug in at random. Make sure you plan your approach, like play a heads-up game here. To get a no, you want z to be as big as it can relative to x and y. Be as big as it can be. As big as possible. So let's take a look at what we can do there. Well, let's try random x's and y's. Let's say that x and y are 3 and 3. Who knows why? So then this would be 9 plus 9 in our checkpoint here. So as long as z squared clocks in under 18, then we're good. Let's let z be 4, because that'll work. So 9 plus 9 is, in fact, greater than 16. So then x to the 4th is 9 squared, that's 81. Y to the 4th is also 81. And z to the 4th is 16 squared, which is 256. This is a no. 256 is bigger. So 7, 8, and 10, that would also accomplish, I believe, the same thing, because 49 and 64, yeah. So it's not really that bad to come up with these cases, but if you are not organized about things, then it is. Like if you're just throwing random integers in there, then you probably won't come across it. But if your approach is organized, then this is all good, right? So we got ourselves not sufficient. So this is not sufficient either. But then if you look at the statements together, if you look at that, the same two cases still work in statement 2. Like 1 plus 1 is bigger than 0, and 3 plus 3 is bigger than 4. So you can actually use the same two cases. So overall, E. Suvik, I don't really know that there's a fast algebra way to do this. I mean, like because the terms that you get in there are not, you can't solve for that inequality in some easy steps. So there might be some algebra that you could do here, but it's going to be very tedious. And it'll probably involve breaking something down into some sort of cases. But that's what makes this problem so crazy, is that there's no easy way to manipulate those statements into proving that that's not true. But if you, I mean, the best approach, again, is to have as many approaches as you can. So if you have an algebra approach and you can do this, then that's where you want to be. So, okay. All right. Anyway, any other questions about this fraction question? This question, I'll just throw it on the board. The reason I'm saying you don't, I didn't say don't use fractions. I just said you don't have to. Fractions take most people longer to deal with and are more of a pain. So if you can get it to work with fractions, then do it. But you just don't have to. You can stick with nice, familiar integers and turn out to be fine. So, yeah, if that's what I'm saying. If you square statement 1, then there's no easy proof from that. Like if you, I mean, since people are talking about this anyway, let's just go ahead and look at that. So if you try an algebra approach here, if you try squaring statement 1, then that's x to the 4th. I mean, it's x squared plus y squared squared. So that's x to the 4th plus 2x squared y squared plus y to the 4th is greater than e to the 4th. So let's put the exponents in there. The answer to any question about difficulty level is you don't care. It's just a problem that is in front of you. And you have to, those are the wrong exponents. Sorry, that's the 4th. That's the 4th. This is the 4th. So, I mean, the problem is that this is an extra term. There's no way to just, like, neatly kill this term. So you have, I mean, this is x to the 4th plus y to the 4th plus other stuff is greater than c to the 4th. So that's not proof that x to the 4th plus y to the 4th is not greater. It's I mean, this means that we don't have any idea what the relationship is between just this and just this. So the other steps is a square term. I mean, I can give you I'll give you 2 examples here. I don't want to chase this thread forever, but let me just give you 2 examples and that'll help. Okay, so like, the point is that if you add other stuff and then it becomes greater, you don't know what the effect of that other stuff is. Like that's conceptually what's going on. So like here are 2 examples. The first example is, I mean, I'll use kind of trivial examples to show you why this doesn't work. Okay, like an example, we know that x plus 1 is greater than x, right? But if I say x plus 1 plus other stuff is greater than x, I mean, this is true. But in this case, it's still true that x plus 1 is greater than x. On the other hand, if you were given, you know, x plus 1, x minus 1 plus positive stuff is greater than x, then you would not know, of course, that x minus 1 is greater than x. I mean, those are 2 examples. Those are not brilliant examples or anything, but they should show you that this is not going to work. Yeah, but you do the same thing here. I mean, again, I want to end this particular part of the discussion here because this is not the point of today. The point of today is this. Make sure you can do this testing cases thing in a way that is organized. That's what this is all about. So, okay. Let's look at this. How about coordinate geometry problem? Okay, go for it. Go for it. Here's a timer. Okay, there's still a number of you who don't have answers here, so give that a shot. Give it another 20, 30 seconds, and let's get cracking. Okay, ladies and gentlemen, here are your responses as a group. So there seems to be a consensus here on choice C. So let's take a look and let's go from there. So all right, lines N and P lie on the XY plane. Is the slope of line N less than the slope of line P? So let's talk about this with a case testing approach. There may be ways that you can wrangle with the mx plus b type thing to make this happen, but when they give you coordinate geometry problems, what they are usually doing there is they're usually visually based, or at least they have a strong visual component. So coordinate geometry problems, especially of the data sufficiency variety, usually have a strong visual component. What this also means is that you should try the visual component first. I mean, there's actually 2 entire study hall sessions on this. There are 2 sessions that are dedicated to coordinate geometry DS. But when you see one of those problems, you should first try to visualize, because if visualization works, then it's quicker. If it doesn't work, it's still quicker. And then if you can't visualize the problem, then try algebra. So, you know, a y equals mx plus b type approach, and so on. Because the thing is, if you try algebra first, it will probably not leave you time for other things, because wrangling with mx plus b in all of these different situations is, it eats time. So you want to make sure that you get the quicker thing out of the way first. And in this case, that would be the case. That would be the visualizing type of approach. So let's look at that. Let's try to visualize. Lines N and P intersect at the point 5, -1. So let's scratch up a set of coordinate axes here. Oops. Scratch it up like that. Okay, let's say that we have these coordinate axes, and then that's x and that's y. Okay, and then let's say that this is the point 5, 1. And it's not a very pretty 5, but you'll get the point. Okay, so what are we doing here? Well, there's the point where they intersect in statement 1. So is the slope of n less than the slope of line P? Let's make sure that we define what sufficient means before we get started here. So let's kill those ugly numbers and let's put in real numbers. There, 5. And then let's scratch that and put 1. Okay, so that's the question. Let's make sure we define before we even kick this off. We got to define what sufficient and insufficient mean again. So insufficient means that what can happen and also what can happen. Chat box. Like, in other words, what goes in these blanks. Yeah, you can get, it doesn't have to necessarily be careful with this, guys. The opposite of less is not greater. The opposite of less is greater than or equal to it. So make sure that you are, because I mean, I don't think a problem is ever going to come down to that, but it certainly could. I mean, there's no reason why they couldn't do that. So it's possible that slope n is less than slope p. That's a yes answer. And it's possible that slope n is greater than or equal to slope p, and that's a no answer. So slope greater than or equal to is what that says. So let's try to get that to happen. I mean, if you just have the, and then sufficient, on the other hand, means that only one of these can happen. So again, defining insufficient is easier on yes/no questions, starting with insufficient. But sufficient means that only one of these two things can go down. So that's what that is. Insufficient is this, sufficient is that. So, okay. There. If you have lines M and P intersecting at 5, 1, I mean, it's, let's make a couple of copies of that picture. And then, it's not very hard to make that happen, but just make sure you understand how that works. So here's two different axes, one for the yes, one for the no. So for slope n less than slope p, you know, just draw, let's say that this is line n. What happened there? Okay, let's just make line n do like that. And then let's let line p go like that. So that would be a yes to the question, because the slope of line n is less. There's a bunch of ways you could draw that, but then you can just draw it so that it's no. So here's line n, and then here's line p. So switch the roles of the two lines. That's a no. So this statement's not sufficient. The y-intercept of line n is greater than the y-intercept of line p. Let's take that to the next page. So remember, what you're trying to do is this. So for statement 2, what is happening is that here's one set of coordinate axes for a yes, here's another one for a no. So any y-intercept that's greater than any x-intercept here, basically. So here's a greater y-intercept. Here's a lesser y-intercept. Here's a greater y-intercept. Here's a lesser y-intercept. And then, so line N has the greater y-intercept. You can just make that slope less than P. So this would be a yes. Or you can make it slope more than P. So, and now has a bigger slope. That's a no answer. So this one's not sufficient either. Any questions about the individual statements? Okay, let's take all this fun stuff over to the next page and use the two statements together. So, there we go. So two statements not by themselves taken together. The two statements together. We know that we have to go through the 0.15. So conveniently still have that graphic from before. And then let's, just to make this a little bit clearer what's happening here, let's make N a different color from P. So let's make N this color, and then let's make P this gray. Okay. So N has to hit the y-axis higher than P does. So what you're going to notice here is you can get a yes fairly easily. Here's, let's say we have line N. So if line N is here, for instance, y-intercept, and then line P is over here, then here you have slope N less than slope P. The question becomes, can you get slope N to be bigger? Can you get a no here? Can you get the slope of N to be bigger than the slope of P? Chat box. We're not a quiet crowd today. You can't, Erica, you can't. A couple other people are typing. Let's see if we can explain why not. Line P anti-clockwise. I don't really know. Belanger, I don't really know what you're saying there. It turns out you can't get a no. In other words, you can't get N to be parallel to or to have a higher slope than P. Yeah, like, I mean, the deal is this. If you look at this situation, slope is, you know, how much do you go up or down per unit. And I mean, if you're starting higher and you're getting to the same point, then you have to have a lower slope. Because line P, let's color code here. Line P has to start lower and still make it to this 0.51. Line N has to start higher and still make it to 5.1. The only way that both of those could happen together is if P slopes more, if P gains more coordinates per how much it moves over to the right. So, but you can just try to get this case and it's not going to happen. There are probably also ways to use MX plus B here, but those are not the point of this session. So, but you can't get this to occur. So with the two statements together, the only possible outcome is that the slope of P is greater. So that's a yes, always yes to the question, so sufficient, and our overall answer to this is C, like cat. Any questions? Joel, maybe. I mean, if you, here's the question that Joel is asking. Joel's question is this. I mean, this would be something you would do not all the time. A couple of observations here. The first is, I mean, because this is an important thing to think about, right? The first observation is if your approach is organized, then doing all of these things in that time still shouldn't really be a problem. So I mean, that's the best answer I can give is that. But here are a couple of other observations here. Observation 2 is that you won't always have to do the blue thing. In fact, 60% of the time you won't. Because remember that if the answer ends up as A, B, or D, which is fully 60% of the problems, then you won't have to combine the statements. Also, one thing you'll notice about these problems is they are kind of nice to you in the sense that on GMAC problems, if you have to combine the statements, one or both of the individual statements, which you have to do first, is or are usually quite easy to resolve. In other words, what they're not going to do is make you do a bunch of labor. I mean, it's important to understand this. They are not slave drivers here. So you're not going to be like doing tons of work for statement 1 and tons of work for statement 2 and tons of work for the two statements together. Just like in the problem with X and Y and Z, last time, they're going to make it so that if you resolve statement 2, oh, you've accidentally resolved the whole thing. Or last observation, which ties into this, is number 4, you might also, like, if something seems like a lot of work, first, check your intuition to see whether something is clearly insufficient before starting work on it. Because, I mean, what I'm talking about with number 4 is this. Like, I went ahead and drew all these on the board. But, here's statement 1. You don't really have to do this. Like, you don't actually have to visualize both of these. Like, you can... I did it just to show the testing of cases here, but you should be able to just intuit the idea that this is not good enough. You can just realize that, not supposed to be a comma there. I mean, all you have here is an intersection point. You don't have anything that would determine a slope at all. So if you realize that, then you can skip even having to find these cases because you know that the slopes can be anything at all. Like, if that's all you have, then P and N can have any slopes at all in the world. So that's not sufficient. Same problem here. I mean, this is just for y-intercepts. You only had a fact about y-intercepts. So your slopes can still be anything in the world. So still not sufficient. So I mean, you'll have shortcuts like that. Finally, let's talk about this comment real quick. How about this comment that's in the corner of the board right now? Does anybody have any thoughtful response to that? If you've seen my previous study halls, you might actually even know what I'm going to say here already. But in particular, I don't, that's true. You might have differential time here, but I don't love the way that a couple of you are saying this. So let's have a quick chat about this before we call it a day. I mean, what is this whole full time thing? I mean, is 2 minutes a full anything? Make sure you guys are on the same page about this. What is 2 minutes? When we talk about 2 minutes for a quant question, what is that? But would you have to even compensate for 2 minutes? I mean, I think some of you guys are thinking that 2 minutes is like this ridiculous amount of time to spend on a problem. And then some people are saying things that are just absolutely not true, like this. I mean, no. Straight up answer to this is no, absolutely not. So let's chat about this. Is 2 minutes, quote, the full time, unquote? Do you even have to compensate? Is this true? I mean, the answer to all of these questions is no. So first, let's get back on the same page with, like, what is actually 2 minutes? What does the 2 minutes mean? Let's have someone dump that in the chat box. Like, what quantity is actually 2 minutes? Aha, it's an average. Oh, hey, let's talk about that. It's an average. It's not a limit. It's not a maximum. It's an average. So that's an average. So I mean, there's a couple of things you guys have to notice about this. I mean, this is definitely false that all questions should take 1.5 to 2 minutes. If that's true, then you will wind up sitting on your hands for like the last 30 minutes of the quant section. I mean, you cannot be below average for everything. That's not what an average is. That's not how they work. Same thing with compensate. I mean, what you have to compensate for is if you take longer than average. But, I mean, taking 2 minutes is the perfectly average length on a problem, so there's nothing to compensate for. So the point here is this. I mean, we're sort of running out of time here, so let me keep this short. But the point is that if a problem is longer than you can and should spend more than 2 minutes on it, unless you're stuck. And then if a problem is really short, yeah, like word problems. And then if a problem is shorter, then you should spend less than 2 minutes on it. So, like, let me give you examples of what I'm talking about here. I'm going to use official guide problems here as an example. I can't reproduce them on the board in full, so what I'll do is just put the first few words of each one, and then you can go look these up in your own official guides. But I'm going to use 2 problems from the guide as examples here. And I can only reproduce parts of these so that I'm not running afoul of, yeah, I'll post the numbers, so that I'm not running afoul of copyright laws or whatever. But here are two problems from the official guide, 12th edition. So, reproduced only partially for fair use. And these are copyright, of course, GMAC. So, if you go look up this problem, these are in OG13. They're somewhere really close to those. I think they're maybe one or two problems off. So they might be 164 or 165 or 162 instead of 163. They're in there. So the point is that no one will finish this problem in 2 minutes or less. That includes instructors who have taught these kinds of tests for 20 years. Not going to happen. There's way too much stuff to do there. You have to absorb what's happening in there. You have to translate it into mathematics, and then you have to do that mathematics. So, I mean, this on a really, really long problem, it's perfectly okay to spend 3 minutes, maybe even a little more. I mean, this is really kind of common sense. This is how averages work. Like, if you paint a house in an average of 4 hours, then if you have a gigantic mansion to paint, you would not still expect to paint it in 4 hours. I mean, nothing genius about that. This problem, the one that's right after it, this is a one-step problem. So if you can solve it, it should take no more than 15 to 20 seconds. And then if you can't solve it, then you should make that realization in no more than 15 to 20 seconds. So in other words, everyone should finish this one in under 30 seconds. So, yeah. Okay, let's see. What is this? I'm going to answer these quickly because I'm kind of on a schedule here, so we need to go pretty soon. But let me address these last couple of points about this. I mean, in the actual exam, you do have a timer. Sure you do, but you just don't want to be looking at it all the time. So the point is that there's a couple of comments in response to this. I mean, number one, you obviously don't have to know where the timer stands at all times. You don't have to know exactly how much time is left every single problem. But first, I mean, yes, you do get a timer, although you should hide it for most of the time so that it doesn't distract you. I mean, there's a timer in the corner of the screen. But also, the point here is this is why you take practice tests. You know, the main reason for taking a practice test is not because you don't learn things from full-length tests, right? You evaluate, you diagnose, but there's no learning taking place there. I mean, so if your goal is to learn how to solve the problems, then full-length tests are actually sort of useless. But one big advantage of full-length tests is that it lets you practice this kind of time management. So it's to get used to this rhythm. And the most important observation to make here is you should only have to look at the clock every like 5 to 10 problems. If you actually quit when you are stuck in the interim, then your overall timing will be fine. this is really important. Like, if you actually have to look at the clock every single problem, or if you want to look at a stopwatch every single problem, then that means you have bad time management. That doesn't mean you have to be more precise about that. It means you don't know how to quit. So the point is that you shouldn't even really be thinking about time all the time, because if you can quit, then you can quit. So that's the most important thing to say in response to that, because this observation is totally on point, this one right here. If you look at the clock every single problem, you will probably throw away a total of 5, 6, 7 minutes just looking at the clock. And I mean, that's time that you could have spent solving problems. So you should get to this point where you have a rhythm that is workable, where you can just look at the clock every now and then. And, you know, maybe not when you first ever start doing these problems, but I mean, this should happen pretty soon. It's just being able to quit is what it is. Okay, that's about the main point of what I have to say there. We do have to close up shop here in just a second, because we are now over time by about 6 or 7 minutes. As many as possible, not really. I mean, you just want to take enough that you have a rhythm, and enough that there's no reason to take like 20 practice tests. That's just a waste of everybody's time. But unless it takes you that many to get used to the timing. I mean, you should take enough where you can proceed through the whole thing as a routine and you're used to the timing. Okay. Subic recalibration, they sent out a notice that would tell you everything you need to know about that. I wouldn't be able to tell you any more than the notice that you got. In fact, the notice could tell you a lot more than I could. So, all right, let's go ahead and call it quits. Have a good night. Good night and good luck. We don't ever know what the study hall topic is until about 2 hours before the study hall. So the answer is I have no idea. Okay, so thank you guys for attending, and good night. Good luck. We're going to call it a night.